Hello everyone, welcome to the second day of Arena development training. Perhaps I can start off with a quick recap of the things that we discussed yesterday. So yesterday we basically didn't discuss anything specific to IFS, but we just tried to set the background, fill up the required knowledge gap that you might be needing to understand how Arena framework is working. Just like I mentioned yesterday, uh, you do not need to have a very good understanding about these concepts in order for you to develop IFS Arena. But of course, if you need to understand how Arena works behind the scene, then you need to have a good understanding about these concepts. Plus, if you need to debug certain issues, then having a good idea about this concept might help you to uh, make quick decisions and also try to find out the reasons for certain issues very quickly. Right. So yesterday we started off with HTTP basics. We discussed about HTTP protocol, a communication protocol, and also we discussed how the communications happen between a client and a server through requests and responses. And we also discussed about different types of headers that are included in these request and response messages. And also optionally, they have a message body which can contain additional data. For example, if you're trying to insert a record into the server, some of the tables that are residing in the server, then the client will be sending in an HTTP request containing some additional message body, including all of the data that it needs to insert. And then we also discussed about HTTP request methods or HTTP verbs. Basically, there are verbs such as get. Whenever we are trying to retrieve a value, we will be using HTTP get. And if you need to modify a certain record in the server, you will use HTTP patch requests. And if you need to delete a record, HTTP delete. Likewise, there are many different HTTP methods that you can use. But of course, if you're using a browser's address bar, always when you're typing something in the address bar and when you hit enter, it will be sending a HTTP GET request, which is why we have used the Postman tool where we can simulate additional HTTP methods too, such as patch and post requests. We also talk about two different data exchange formats, XML and JSON, very familiar data exchange formats that we have as of today. We try to compare the two, and also you need to have an understanding about these two data exchange formats because both of them are involved in the OData protocol. For example, in OData protocol, we have two types of document that we can expose through the service model. One is a service document, which is containing entity set information and function information. So that will be based on JSON. And also you have a document called a metadata document, which will describe entity data model. So that will be in XML format. Also, consequent requests and responses, the data that we are exchanging between the client and the server will be in JSON format. And then we talked about web services. The concept of web service, basically, we asked around what a web service is. Most of you all had different definitions, but altogether made up a good definition for what a web service is, right? Basically, when you have an application called application A, and there is another application called application B. Application B might be exposing certain set of services that application A can consume. So this application to application communication simply can be happen through the web services. Basically, if application B is exposing certain set of web services, app A can consume those web services. Most of the times, the invocations for the HTTP request will happen over the internet. For example, application A will reside in your local network, whereas application B might be a third-party service like Facebook Graph API, where we try to access that service through internet. But it's not really that, but also there can be other scenarios where you have services exposed internally through within your local area network. For example, if you're hosting an application on premise, maybe within your application, there is a client-side application as well as a server-side application. And the server-side application might be exposing a couple of web services. So same thing happens with Orina. We have a server-side application running, which is known as a OData provider, which will be exposing the necessary web services that can be consumed by the Orina client. And also we discussed about RESTful web services. What is the difference between web services and RESTful web services? Basically, REST or the REST architectural style, they have introduced some of the constraints that you can follow as a developer. And if you make sure that these constraints are followed within your web service development, you can tell that your web service is a RESTful web service. Right, so there are certain constraints such as cacheability. You ensure that certain data can be cached. Only if the data is modified, you need to retrieve the new version of this data and so on. And also uniform URL that you can use. For example, when you need to consume some type of a API, whatever the request URL that you're writing can have a specific pattern. If you need to retrieve two different types of objects, the pattern of the URL should be the same so that you have a uniformity in the URL. So likewise, there are certain set of constraints that you need to follow. If you do that, then it can be called as a RESTful web service. And on top of that, we can have another standardization layer using a protocol called OData protocol. So OData protocol specifies a set of rules where if you made sure that you're following or you're adhering to these rules, then maybe what you're getting at the end is a RESTful web service, because OData protocol will make sure that you're implementing a web service that is RESTful as well as that is further standardizing certain aspects of your web service, such as the URL convention. OData provides its own specific URL convention where you have to adhere to that. So two different web services who are adhering to OData protocol will have the same URL convention. And also it will need to map their underlying data structures into what is known as the entity data model, so that in two different web services, they can have different types of entities referred to by the same type of keywords. For example, if you say entity sets, application A can expose some entity sets, application B can expose another different set of entity sets. But how you have to query them through the service endpoint would be the same using the similar type of a URL, which is why IFS is also adhering to OData protocol. Yeah, so that is a quick recap of the things that we discussed yesterday. And towards the end of yesterday's session, we also showed you how to test some demo OData web service using Postman as well as using the browser. I believe most of you are able to test it out as well, just to get a feel of it and just to understand these different URL syntaxes that you can type in. Right. So today we are moving on to IFS Orina architecture. But before we talk about IFS Orina client itself, let's try to understand what sort of web clients that we had in earlier versions of IFS applications and why we decided to move to IFS Orina, a different type of a web client. Right? So let's first of all have a look at this particular diagram where we try to discuss about our traditional web applications that we provide in earlier versions of IFS applications. For example, in IFS applications 8, 7, and even in certain sections of, I would say in very early versions of apps 10, we had this so-called traditional web application or the traditional web client, right? So before I go through this diagram, let me show you how it looked like in an older version. So it looked something like this. So this is relevant to an IFS applications 8 instance, and I have loaded a specific page containing some case detail, right? And the problem that we had with this old web client is that when we interact with this web client, let's say we need to perform some sort of an operation. The end user needs to query some data, right? So if they need to query some data, look for some case IDs, there is a search icon at the top right corner. When you click that, what happens is your entire page gets loaded. So I think it got reloaded because it expired. Now, if you click search, your entire page get replaced and reloaded, and then only you will see the search parameters. And then you will add the search parameters. And when you click search, again, it will try to search all of the cases that you have. Right? And when you press add new, then again, you can see you're refreshing the entire page. So this is the problem that we had with old or the traditional web client that we had in older versions of IFS applications. What's the problem? Usability. Because if you see this in an end user's perspective, it is not a very good experience, right? When they interact with the client, they have to go through a lot of different page reloads to get something done. This was not very good. So how did it work back then in the traditional web application? We had the web client and we had the some of the data exposed through some web services or some enterprise services hosted in a Java enterprise application server. Then whenever a user requests for a certain web page, or whenever a user tries to interact in a web page, like clicking on the search button, there will be an initial request sent to the server. And then what server does is it will send back an HTML page containing some optionally some additional JavaScripts. So the first time that you load this page, you are sending in HTTP request, then you will get this HTML page rendered in the browser. Then afterwards, for the consequent user interactions, when you press the search button, when you press the new button, what will happen is, again, the browser will be sending a form post. You are doing HTTP post to the server. So that server will be sending back a new page with the data optionally. So this new page will be replaced with the current page. And that is why there will be a reload happening. So this is how our traditional web application worked. And let's see now how our Arena web application is working. But before we talk about how this Arena web client is working, I have noticed some of you have not experienced in Arena application. Some of you have worked with Arena application in apps 10 version. But just to get a feel of it, let's try to log into our VMs. And we have already created an IFS applications instance, a unique application instance for each and every one of you. So this instance is of version IFS Cloud 22 R1 service update 1. Let me show you how to access this instance from within your VM, and then we can just browse through the Arena client just to get a feel of it. And then we will come back to the slide and discuss how it is working behind the scene. Right. Let's try to log into our VM. Okay, I believe all of you are able to log into your allocated VMs. And once you are inside the VM, you should see these set of icons. And to run Arena client, we recommend Google Chrome or Microsoft Edge Chromium version, and also the Safari browser. Firefox is not within the recommended list, but it will also work, although it is not included in the supported platforms documentation. Right. Now, when you're inside your VM, can you go to the Explorer, and in your C drive, you should find a folder called Training Resources. And inside Training Resources, you will find a Arena Helper text. If you open it up, it will contain pretty much all the necessary information that you need to log into the Arena client. Plus later on, you will also have to connect to the database for development purposes. Right. And under Arena client login, you will have this access point URL that is some prefix plus the last 3 digits of your allocated VM. So currently I am working in VM 106. So you should, I will be replacing this with 106, but you should replace this with your allocated VM's last 3 digits.
Excuse me?
Yes.
Can you show me again where I find the training resources?
Okay, sure.
Folder?
So if you go inside the VM C drive, there should be a training resources folder.
Okay, yes, I found it.
Yeah.
I also want to ask, today the chat seems to be disabled for me at least. I can't.
Okay, what about others? Others, can you access the chat?
Yeah, it's actually the same for me. It's Grigory here. And we are actually logging in from the browser because we don't have the local Teams installed.
Okay, probably because you have logged in as guest account. I think that's why the chat is disabled for you all.
Okay.
Yeah, in that case, please do unmute your mic and mention if you have any issues so that we can look into it. Yeah.
Okay, thank you.
Yeah. One other thing as well. I'm actually trying to connect to the the VM again because I'm not able to actually connect to the the mentioned computer. So I get an error. So I try to actually reconnect now. So it's taking a bit of time, just that you know.
Yeah, no worries. I'm just showing how to log into the Arena client. You can just have a look at this as a demonstration too. But when we start the developments, of course, just make sure that you have access to the VMs, right?
Yeah, absolutely. So I'll try it now. Yeah.
Okay, no worries. All right, everyone. So within the training resources, you will have this Arena helper where it will indicate this access point. So earlier I had a suffix or a placeholder for your access point name. Basically, it is a certain prefix plus last 3 digits of your allocated VM. So make sure that you are not referring to anyone else's application instances because that has happened in previous training scenarios, which has also caused a lot of issues. So please make sure that you use your own allocated VM number here. Right. And once you're done, you can simply copy this URL. And if you're wondering what this particular URL points to, simply you might see this is representing a certain host. So this is a Linux host actually containing or hosting our middle tier. So for each and every instance that we have allocated to you all, there is a separate Linux host which is running the middle tier also. So basically to run IFS cloud locally or on premise, you need a database server and an additional Linux host to deploy our middle tier or the Kubernetes cluster. So that's what you are connecting to here. So you can copy this URL and then open up Google Chrome, paste it, and you should see a landing page like this. Now, once you have accessed the landing page, of course, you will get a couple of different options. Among these options, to access the Arena web client, of course, you have to use this IFS Arena option. So let's click on IFS Arena. You should obviously get a login page like this. And the credentials are IFS app, IFS app. Those are the client credentials related to application owner user. You can enter the password in lowercase, but username is not case sensitive. Okay, I think I have a session issue. Right. Okay, so this is how Arena web client looks like in IFS Cloud. Basically, you will be presented with this welcome screen, and look and feel wise, of course, it might be a little bit different if you compare it with Arena client that we have in applications 10. But in development perspective, how you have to develop the two clients in Apps 10 and Cloud is pretty much the same. The syntax is almost the same as well, right? And in here, you will see at the top right corner an option bar or a command button with your username. And there are a couple of different options available here. Account settings, which will show you the current user ID. If you need to change the language, you can do so, but currently we have only installed English language. And also there are a couple of other options which we will be going through later on. For example, this so-called debug console, which is quite important for you to debug certain Arena development scenarios. And most importantly, you can click on this home button if you need to go back to the home page or the welcome screen, if that is the home page. And on the left-hand side, you will see this icon with 3 dashes. Right? I don't know if there is a specific name for this type of icon. If so, let me know. You can click on it. Once you click on it, it will open up what is known as a navigator. So if you are familiar with applications 10, in our .NET client, we also had a navigator. So this is the main entry point to access the different types of pages that you have available within the client. But you might see we only have very few number of entries. That is because this installation that we have done is a demo installation using a very few number of components because we didn't want to overcomplicate by installing all of the components. Then you will see hundreds of entries in the full version of application relevant to different types of product areas. But we will try to we have installed this demo installation because then you can specifically focus on your development, and it will be easier for you to also spot the new entries that are getting created here as you develop the workshop. Right. So anyhow, usually you will see lots of entries in this navigator which are relevant to different product areas. And as you activate different components, you will see more entries appearing here. And if you click on a particular entry, for example, solution manager, then you have sub navigate entries. If you click another entry, you can traverse through the sub navigate entries and finally arrive at an entry, which is not a sub navigator, but a particular entry which leads you to a page. Now, when you select a particular entry here, you will see on the right hand side, the page that we try to access got loaded, right? But if you have a look at the navigator, the top toolbar, and so on, they actually did not change. Only this dynamic part where the page get loaded is changed, right? So if you try to access a different page, for example, there is a page, a very simple page known as units of measure. So if you all can access it, application base setup, unit of measure, units of measure. So once you access this navigate entry, on the right hand side, there is this dynamic section where your page gets loaded. Now, usually we use a term for this type of a web application. Whenever you access a particular page, that page gets loaded on the right hand side. And when you access a different page, again, your page is replaced. But your basic functionality, like the navigator, the top toolbar, remains the same without any changes, right? Do you know what's the term that we use to mention this type of a client application or a web application? Anyone? There's a specific term if you are familiar with web development. Have you heard the term single page applications? So what we have in the Arena client is quite similar to a single page application, right? SPA. So that means whenever you are working, you will load this particular single page, and as you interact within this page, for example, I will access the unit of measure, and let's say I need to query some data. Now, initially you will get some set of rows queried for you, but you can also use this filter panel icon to query by field. Right? So if I query by maybe description, starting with AM, I can hit enter, and then all of the description starting with AM is listed here. But if we compare this with the our traditional web application that we had, you might have noticed whenever you query, it does not reload the entire browser page. It only updates the necessary list where the data is being changed. The other part of the page remains unchanged. So this is how the interaction happens within a single page application. And whenever you need to add a new record, when you click plus, your page does not get reloaded, but only it will try to add a new record or a row into this particular list, and then you can go ahead and add the values. And what is highlighted in sort of a pink color are mandatory fields, and then you can click save. And also when you click save, your page did not get reloaded. So also quite important to understand, there are two ways that you can reload a page in Arena. One is the browser reload. So browser reload is this reload button that you see at the top. Right? So when you do a browser reload, it will reload the entire page. But instead of doing that, if you need to just refresh the data, maybe someone else has updated the data and you need to see the changes. If that is the case, can you see there is a small refresh icon at the top of the page, the one I'm pointing. Right? I try to zoom in, but yeah, this small refresh icon is doing the page level refresh of the data. Right? Usually when you are developing, if you try to develop a change to this page, that change that you did to the page will take place only if you do a browser refresh. Then only your entire set of client changes will be reloaded. And if you do this small refresh, which is the data refresh, that will take effect only if you have changes in the data. Right? So that is quite important. Whenever we ask you to reload the page, then try to do the browser reload. And there are certain times we will ask you to do a data refresh as well. So if that's the case, you can use this option. Right. So basically, this is how the Arena client looks like. In the full version of the applications, you have hundreds of thousands of pages and certain features as well, but nothing to worry. We will start from a very small exercise where we create a very simple page, and then let's try to build up from that point onwards. Right. Do you all have any questions relevant to what we have discussed so far? All good?
Yes, I'm sorry.
Yes, Janos. Yeah.
Can you have multiple screens at the same time in front of you? I mean, multiple IFS forms.
Multiple IFS forms, in the sense, you mean multiple pages, is it?
Yeah, what this Enterprise Explorer is capable of. So,
yeah,
is it possible
it's not possible in the Arena client. Always when you access a new page, the current page will be reloaded. But if you need to do so, then you can load it in multiple tabs. Right. So for example, you can do this.
Okay.
Start it in a new tab so that you can work with it separately. Right. But just like in Enterprise Explorer, it won't work open in a new window. There's no option like that. Yeah, this just works like a, yeah.
Okay, thanks.
Any other questions? Okay, I see some trying to test the chat as well. For Roy, I think it worked fine. Right, I'm going back to the slides. Yeah, now we are going to discuss about how this Arena client application is working, and we will also see how it was different from our traditional web application. Now what happens is whenever a user interacts with the client, like you have seen, only the specific section of the page that is affected by that user's interaction is getting refreshed. Whenever you query data, only that specific section is getting refreshed, not the entire page. So how do we achieve this in Arena client? Of course, initially when you're accessing the Arena client, the first time, let's say you open up a browser and log into the Arena client, then we will be sending an initial request to get this initial page. So what I mean by that is this particular page that you are getting, right? So this particular page that you're seeing here contains a static section, right? This navigator and the top toolbar are sort of static, and this section is sort of dynamic, right? So what you get initially, this static section is known as Arena shell. So once you send in the initial request, it will download a certain Arena shell, a certain component known as Arena shell, which is part of our IFS web component, the Arena client runtime running within the browser. And then as you perform certain options within the Arena client, then only the affected area of the page will get refreshed. So usually the server will be sending us back with a HTML document plus some JavaScript libraries. And then any consequent user interaction that you do will result in AJAX requests. So what do we mean by AJAX, everyone? I'm pretty sure some of you have heard this term AJAX. Anyone?
Is it the RxJS Ajax method?
Sorry, I couldn't hear you clearly.
The RxJS, is it related to RxJS?
No, not really only to RxJS, I would say. So Ajax, so let me explain. So this is a type of a web development concept and a sort of a technology. Basically, Ajax stands for asynchronous JavaScript and XML. So this X stands for XML. What this does is this will allow the browser to send certain requests to the server in the background. For example, if you have a page opened like this and you go to a page and then you perform some operation here. And when you perform an operation like a search operation and hit enter, the browser in the background, it will send a request to the server. The browser will send a request to the server in the background, and then server will try to find out the relevant data and send back the data. In IFS scenario, it will send back the data in JSON format. Right? So originally, Ajax standard for asynchronous JavaScript and XML, but there's no strict rule saying that you can only use XML, because in IFS we are using JSON. In most of the current scenarios in other applications as well, most of them are using JSON. Right? So this X in the Ajax could be quite misleading too. Right? So server will have a look at this request and try to find out the data, maybe by executing a database query, create a JSON document and send it back to the client. Now, in the background, client receives this JSON document. Ideally, when you're querying data, client will receive a document containing this particular record. Because for this particular query, we only have a single record. right? And then what the client will do is client will update the page in the background. So basically it will manipulate the HTML DOM and update only the necessary section of the page without reloading the entire page. So this is what Ajax enables, right? So it basically allows web pages to be updated asynchronously so that you don't need to reload the entire pages. You can update only the necessary part of the page. I believe this is clear, right? And whenever the client is requesting some data from the server, that happens through RESTful invocations. Basically, client is consuming a RESTful web service. Obviously, that is also conforming to OData protocol in IFS. Right. So let's try to further understand how this happens behind the scene. If you have a look at the key components for the Arena client, of course, within the browser, we are running a component called IFS Web. So when you send this initial request, I told you we are getting an initial shell called Arena shell. So this Arena shell is part of the IFS Web component. So not only the visual shell that you're getting, and also there are certain underlying JavaScript libraries based on AngularJS as well. So all of those components will be downloaded into your browser. That is a one-time thing. And then you also have a container within our containerized middle tier. Most probably you all know that in IFS Cloud, the major change that we have is that we have changed our middleware server, what we had in applications 10 from WebLogic server into a containerized middle tier. So basically, this containerized middle tier is represented using a Kubernetes cluster. And within the middle tier, we have deployed a couple of different containers. They will serve different purposes. We have a container called IFS Connect container, which is responsible for integration. So it works as an integration broker in IFS applications. We have a IFS app proxy container, which is actually acting as the web server for IFS applications. We have a container called IAM, which is responsible for authentication. Likewise, we have many different containers deployed into our containerized middle tier. But what is important for Arena client is this container called IFS OData provider. So what's the purpose of IFS OData provider? That will try to pass the incoming requests, make sure those are valid OData requests, and then it will translate that request into something that the database can understand. So then it will send a request to the database, try to execute a statement, maybe a SQL or a PL SQL statement in the database, get the data back, and again, transform those data into maybe JSON and send back to the browser. Right. So the communication between the browser and the containerized middle tier is always happens through HTTPS protocol, secured HTTP through request and responses. And also this is most of the times OData request. When it needs to retrieve data or perform some sort of operation, it is a OData RESTful web service invocation. But there are certain just HTTP requests as well. For example, this initial request that you're sending to get the Arena shell is just an HTTP request. It is not consuming any web service. And then as the user performs operations, let's say we need to query some data, the web will send a request to the OData provider, and the OData provider will convert that into something database understands and execute it through JDBC. So JDBC is not a communication protocol, it's an application layer protocol. So not an application layer protocol, it's basically TCP. And so you will execute the statement in the database and get the data back and render it in the client again. Right, so this is how it works. And also this IFS web component that we have here is hosting basically the client-side runtime component for IFS Arena. And the database, what does that host? Obviously the data plus significant amount of business logic. There can be certain amount of business logic implemented in the client side. Although you implement that in the client side, you also will have to deploy that too into the database, which is a quite confusing fact, I know. But as we start learning Arena development, you will understand what I meant. Right? So basically, pretty much all of the business logic is deployed into the database and also the data storage. Right. And if we try to have a look at the technology stack, what sort of technologies that we have used for the development of IFS Arena, if we divide the client side and the server side, so basically we have abstracted out the database server. That's mainly based on same base server concepts. So if you think only about the client and our middleware server, in the client side, we are running the IFS web component, which is based on AngularJS, which is a JavaScript framework that we use. And then IFS web will be sending in request to our middleware server, which will be accepted by the OData provider. To be accurate, how it works is in front of the OData provider, we do have a HTTP server. So I will just say HTTP server. This is also running inside an additional container known as IFS proxy. So it will receive the request. It will have a look at this request and determine what is the container that needs to serve this request. So if it is something coming from the Arena client, most of the times it will end up in the OData provider container. Right? So that's some additional information. And to develop this IFS OData provider, we also make use of a third-party library called Apache Olingo. You might remember I have also showed you where this is located yesterday. How can you download this yesterday too? If you access OData.org, and in here you have libraries which will help you develop OData compatible web services. And we are using a Java library known as Apache Olingo. So we are using Apache Olingo within our own IFS OData provider implementation. If I explain why, it looks like this. So in here, we have the IFS web component, and within the OData container, what we do is we try to implement the OData protocol. How do we implement the OData protocol? That is using Apache Olingo, Java library, plus some IFS specific code. That is implemented within the IFS OData provider. So basically, within the OData provider, there are certain IFS specific code. For example, we might need to convert a request into something that the database can understand. So that is something IFS specific. Apache Olingo does not know how to do that. So that is handled by IFS OData provider specific code. Apache Olingo will perform the general OData validations. For example, it will pass the URL into syntax trees, validate our URLs to make sure that is OData compatible. It will also validate requests and responses and so on. Now, if we again compare Apache Olingo and IFS OData provider, simply IFS OData provider uses Apache Olingo to perform these OData specific tasks. Basically, if you need to validate the URLs, validate certain metadata that you're receiving in a HTTP request, and also if you need to generate JSON content, you provide some data. For example, you need to generate a metadata document according to the OData protocol. If that is the case, you provide the names of the entity sets, you provide the names of the navigation properties, fields, and so on. And that will be converted into a metadata document using some functionality available in Apache Olingo. So as a developer, you don't need to do anything. Right? Now, apart from that, within IFS OData provider, we have some additional functionality implemented, which is IFS specific. For example, provide certain metadata specific to IFS functionality. Maybe we need to provide some metadata on how the client needs to be rendered. Maybe we need to provide metadata on if we take this page for an example, and if you need to add a new record, you can see in the client, 2 fields are highlighted as mandatory fields. So how does the client know that it needs to highlight these 2 fields in pink color? That is using IFS specific metadata. Because in the underlying entity, these 2 fields are mandatory. That is why it has to highlight it in the client too. And that's why we need some IFS specific metadata. Not only client side, but also later on you will see we might be using certain server side metadata too. And most importantly, this one, SQL and PLSQL statement generation. Apache Olingo does not know how to do that. IFS knows how to do that. It will have a look at the incoming request, try to map entity sets into one of our already existing base server entities, and then try to invoke some sort of a PLSQL or SQL method. And also it will handle IFS specific security and also expose some client metadata endpoints. And so just try to understand that within IFS's OData provider, we are making use of Apache Olingo. Just like in the previous example that I have explained, the student management system, we have used a Oracle Data Access DLL to connect to the database. Just like that, to make sure our web service is OData compatible web service, we use Apache Olingo. Right. Then we are going to talk about how the data transfer happens for different types of CRUD operations. That means when you perform insert operations, when you perform update operations, delete operations, how the data transfer is happening from the Arena client. Right? So to demonstrate this, I will again go back to the client. Right. And in here, let me access a specific page. You can also give this a try. Maybe we can access the units of measure page that is located inside application base setup, unit of measure, unit of measure. And in here, if you need to have a look at how the client is retrieving these data, obviously you can have a look at the network calls, just like I have demonstrated yesterday. Right? If you right click on the page and inspect, you can get the network pane. By the way, if you need to get rid of the navigator, you can click on this navigator menu again so that it will be hidden. And what I will do is I will open up the network tab. And currently I have a certain network call. I will try to clear it. At the top, you have this clear icon. Right. Okay. Now what I will do is I will try to reload the data. So how can I reload the data? I can do 2 things. I can reload this entire page. If that is the case, this network tab will get cluttered by lots of requests. It will include the initial request that you're sending, handling of the cookies, handling of various different types of requests into the server at the framework level. You don't need to get confused by those requests. Let's try to only refresh the data using the page. So to only refresh the data, what do? you click on this small refresh icon, not the page level refresh. And when I click on that, you can see the client has sent a request, and this is what it looks like. Right? So if I click on this request, you have the request URL like this. And if you need to invoke this particular request, what you can do is you can either double click on the request, or you can copy this and go to a new tab and paste the request here. What are you getting is the data, the refreshed data in raw format, right? So let's go back to the request and have a look at it. We refreshed the page. That means we retrieved data. So that's going to be a GET request. And we got a response 200 OK. That means server was able to find the data required, and it has replied with the data. Now, if I go back to the data that we got, this is in JSON format, as you can see. It contains an array containing values for each record. Right? So all of these are different units of measures that you're getting. So not all of these values will be visible in the client. Some of the values, for example, will represent the version of a record. That is used to make sure certain concurrent operations does not interfere with the state of the data. So basically to make sure the data integrity is there, that whenever a client is referring to the data, Arena will make sure that the client is always updating the latest version of that record. Because when you're working with Arena client, of course, there can be hundreds of thousands of users working in parallel, which is why you need this version to make sure that you are referring to the latest version, right? And we also talked about the fact that this is a GET request. And if you have a look at the URL, let me copy the URL into a notepad. It's quite a lengthy URL. Of course, you have the access point. You have main/applications projection v1 / unit of measure handling.svc / ISO units. And then you have a filter criteria. You might be familiar with this type of a URL because just by having a look at this, you know that this is a OData compatible web service request because we have the filter parameter, and we have the web service root / some entity set, right? So in here, just by having a look at the URL, you might be able to understand that this part until unit of measure handling SVC is the service root which the client has accessed. So that means for different pages, client might be accessing different types of web services. That means IFS application is exposing hundreds of thousands of web service endpoints. Right? And this part that you have afterwards is ISO units, comma. So it's looking for a particular entity set called ISO units. And if you just access service root, what will happen? You will get the service document relevant to that web service endpoint. That is exposing some entity sets, ISO units, some entity sets relevant to a functionality called list of values, and some function as well, right? And if you need to access metadata, what do you need to do? You go back to that and you append $metadata. Basically, you are getting the XML document, which is representing the entity data model representation. And you have an entity set. You have an enumeration called ISO unit type. entity type called ISO unit, many different properties, and entity sets are listed under the entity container. If you have a look at this, you can see there are many different entity sets. ISO units is one of them, right? So if you try to query this entity set through the web service route, you'll probably get all of the data in this case. Right? So by default, IFS is not querying or filtering out a fixed number of rows initially. If you just say this, it will pretty much return all of the data, which is why it is adding the filter criteria automatically. Right? Of course, that will be depending on the filter criteria that you mentioning here. Right? So this is just to give you a feel of what happens behind the scenes when Arena client is loading data. Right? Now, similarly, what will happen if we try to insert a record? So let me quickly show you that as well. So if you click on plus icon, and it is sending a certain request to get the default values. For now, we can forget about this. And maybe I can add a test unit of measure. I just say test UOM, description test. And then you say apply, when you say save, you can see there is a request, in fact, two requests, one you can ignore. This is the most important request that you need, right? When you try to insert a new record, the HTTP method that it uses is HTTP post, right? But if you have a look at the URL, it looks something like this. Now I have a question. What will happen if you take this URL and paste it in the browser tab? Will you insert a new record, everyone?
No.
No. What will happen? You will fetch the ISO unit values, right?
Yeah.
So the URL that we are using to insert a record plus query records is the same. What is the difference? The request method. Earlier we used request method HTTP get, but now when you are inserting a record, we use HTTP post. Now one thing is also missing from our request. What is that, everyone? So when we are inserting a record, you need to send in the information about the new record as well. So that will go in as HTTP request message body. So we talked about an optional message body. You can in fact have a look at that body in the payload, the request payload. So you can see the message body, the request message body contains the new information relevant to the new record that you are trying to insert. So along with that, you are using this URL with HTTP post, which will insert a new record. And what will happen if you modify the record? So you can use this pen icon or the edit icon that you see after you highlight a specific record or multiple records. I will click on this pen. It will change the list view into a certain edit mode. Now in this scenario, you can edit multiple records as well at the same time. But some of the fields are not really editable, right? Because as a developer, you can decide which fields can be updatable. In our case, only the description is editable. I will change the description into maybe test XX. And if I save this, again, we have a request sent. So let's have a look at that request. Now this time, what did you do? We tried to edit a record. What do you think the request method will be, everyone?
Patch.
Any guesses? Patch, right? Yes. So if we select this, you can see the URL would look something like this. But then again, what will happen if you use this URL? Again, you are going to read a value, right? If you use this in a browser's address bar, you're going to read an ISO unit record of which ID is test UOM. So let's try to copy this and paste it here. In fact, getting a single record. But instead, what you need to do is you need to modify this record, which is indicated by this request method patch. So obviously that means for modifications also, you need to include some sort of a payload, which indicates what are the fields that you have changed. So if you have a look at the payload here, you can see the description is the field that we changed, and this is the changed value. Right, so that's how you do a modification. And finally, let's try a delete operation as well. We have the test X. I will select the new record that I have added. And there is this bin icon. If you click that, it will ask for the confirmation. So you can delete multiple records at the same time by clicking multiple records, or just select one that you need to delete and delete. So before that, let me clear this out. Delete, delete. Again, the main request method is HTTP delete, and the request URL itself is containing pretty much the same. Okay, so that okay, because we have deleted the record, it is not found. But initially, did you understand why I'm getting this, everyone? Because I just deleted the record. So if I try to enter the request URL in a new browser tab and get the values, so it will be a HTTP get. But we no longer have a unit code called test UOM, which is why our record is no longer there. But of course, you have to make sure that this is a delete operation. But for a delete operation, do you need a payload? Not really, right? You only need to uniquely identify a record or a set of records, and you don't change anything, you just send a delete, which is why for this delete request, you don't have a payload. Right. I believe this is clear for you all, what I have demonstrated here. Before we continue, do you all have any questions, any clarifications?
Hi, Gregory here.
Yes,
I actually
Gregory.
have a question.
Yeah.
When you actually click on the plus sign there, if
Hmm.
I just take back to where you were before,
Yes.
yeah. So, and if you click on that, in that method or whatever you call it actually. So if you click on the first one there, so
Yeah.
here you have the ISO unit underscore default, a method
Yes.
being called.
Yeah.
Could you please explain how is actually like the client to server communication happening here? Because
Yeah.
are we are still in the client and the prepare where how is it being called and so on? Can you
Yes,
touch
of course.
on it? Actually?
I'm going to explain that in a bit, Gregory, but just for your question, when you click on the plus button, now there are two operations happening when you insert a record in IFS applications. So let me cancel this first. When you need to insert a new record, there are two actions. First of all, you will click plus. It will add a new row, an empty row. And ideally, if you have any default values that the developer has mentioned, those default values will be populated in this row. And then the end user will add any additional values that are needed or change the default values, and then click save, right? So just carefully see what happens here. You click plus, and you can see a new record is appearing. It's still not saved, but meanwhile, there is a request sent to the backend. So this request will retrieve the default values. For example, factor 1 is a default value that we have hard coded in the server side. It has retrieved this default value, but as an end user, you can go ahead and change that. And then you're supposed to enter some values and click save. Then again, another request is sent, which is your HTTP post for inserting the new record, right? So likewise, pretty much all of these requests that we are sending are OData compatible requests. Some will invoke certain actions or functions that we have implemented in the backend. in a while, we will discuss how the translation happens, how this particular request is converted to something that the database can understand. That is something that we will gradually talk about, right?
Okay.
So let me go back to the slide and now talk about the data transfer just as a recap. Like I have mentioned, we have three components. In the browser, we have the client runtime. We have a middle tier. Within the middle tier, a containerized middle tier in IFS Cloud, we have the data provider, and the business logic is within the database. Now for an example, let's try to go through a few CRUD operations, right? So just as a recap again, between the browser and the middle tier, the requests are HTTP, and middle tier and the database, the requests are JDBC. Now let's get the first example. If we need to, now can you guys have a look at this request and tell me what it might be doing? It says the request method as well. What do you think it might be doing, everyone?
Getting people who are over 18 years of age?
Exactly, getting people who are over 18 years of age. So that is just a HTTP GET method, which is a read operation. Now, what the OData container will do is it will have a look at this request, validate it, and convert something that the database into something that the database can understand. Ideally, it will be converted into something like this. Select all from person where age is greater than 18. Right, so that's what the OData provider does. Among many things, that's one of the things that OData provider does. Right? Now, if you have a look at this one, can someone say what this does?
We're adding a post, right?
Yes, it's a post. So that means we are adding a new record, right? Yeah. We are adding a new person called John and age is 25, right? And how it translates to something that the database can execute. Just if you have a look at this, this is a PL SQL package method invocation. I'm pretty sure you're familiar with base server development because that's again a prerequisite of this training. You might be aware that in base server development, we have entities and each and every entity will have its own PL SQL package. But in Arena, on top of that entity specific PL SQL package, we have another wrapper PL SQL package. So what happens is whenever we need to insert something, you would ideally need to invoke new double underscore base server method in some entity package, right? Maybe person API dot new double underscore. But before doing that, it will invoke this PL/SQL method. So because for each and every web service endpoint, we will create a PL/SQL package in the database. And that contains some method called CRUD create. And inside the CRUD create, it will invoke people API new double underscore. Right, so that's how it works. And similarly, this will modify a person whose ID is 2 and is going to modify only the age. And it's going to be converted into something known as maybe package specific to the web service endpoint, CRUD update. And then this will be converted into modify double underscore of the entity method. Same with the delete. It works like this. Right? So just try to understand that the OData provider is responsible for interpreting the incoming request and converting that into something that the database can understand. Right, everyone. So I'm going to now go back to the VM, and we are going to start off with developments. But before we start off with developments, of course, we will be working on some sort of a workshop document, starting off with a very small exercise, and we will gradually increase the complexity. But before we do any of that, I need to give you an idea on what the development would look like for Arena client. Right? So just have a look at the next few demonstrations that I'm going to do without doing anything else. That means you don't have to do this with me. I'm just going to make this just a demonstration. And so I already have a developed page. I'm going to show you how what sort of models are required to develop this page and how I did the development using IFS Developer Studio tool. And so just have a look at this demonstration, everyone. You don't need to do anything. Try to get an idea what we have to do as developers, right? So I'll switch back to a particular instance. And in this particular instance, I have developed a new navigate entry called student overview. So you might not see this in your application instances. Right? When I click this, it will load a very simple page containing list of students. Some of you might be in here as well. Right. Now, let me explain how did I do the development here, just to give you an idea. Right? First of all, the development tool that we are going to use for Arena development is only IFS Developer Studio. There is no other tool required for you to do the development. So I will open up the Developer Studio, and obviously I will go ahead and create a new project. Right? And then you can see I have created a new component called TRNDEM. This stands for a demo component that I have just created. And inside that, you guys should be familiar with this. I have created a base server entity called TRN student. So when I create this entity, of course, let me increase the font a little bit. Okay. Now, just by having a look at this, you know that we have two attributes, one called ID and the other one is name, one having the data type number, the other one having the data type text for the name, right? So you all know how to do this development. And when I try to deploy this into the database, it will create a couple of different database objects, right? So can someone let me know what these different database objects that will be getting created in the database when I deploy the entity?
A view, a package.
A view, a package.
It will create the creation for the table as well.
Yes, exactly. So we will initially have a couple of files generated. We will have a CRE file, which will create the underlying Oracle table and the indexes. One of them is the primary key index, and the other one is the row key index. And then we have a file APV file, which is creating a base view, which is querying from the underlying table that it created. And we have an API and APY. API is a package specification. So basically it will create a package called entity name underscore API in Pascal plus snake case. And here you have all the declarations of public methods and public types. And then you have the APY file, which contains the definitions or the implementations of methods that you have specified in the API. Plus, if it's a private method, then that implementation will only be inside the API. So this is basically relevant to a PL SQL package. So you all know how this works, right? So once you deploy all of these, you will get a table and a PL SQL package and also a view in the database. So those are the three objects that gets created, right? Now, let's assume now I have manually edited the table and inserted some data. For example, these data I have actually manually edited and inserted. And then what you need to do is you need to create this client page. Before you create the client page, what you need to do is you need to create a web service endpoint to expose the data, because otherwise Arena client page will not have some place to fetch the data, because Arena always fetches the data from a OData compatible web service endpoint. Now, to create this web service endpoint, you introduce a new type of a model file called a projection file. So here I have created a projection file called student handling, and you can see we will talk all about the syntax and so on later on, but within the file you can see I only have a single line of code. Apart from these initial attributes I have to set, I only have a single line of code. And by the way, what we are writing here is the Marble language. And we write this, and once you deploy this into the database, all of a sudden, you will have a web service endpoint exposed in IFS, right? So for example, in here, you can see we have used certain terminology specific to OData protocol. I'm asking to create an entity set called TRN students for TRN student base server entity. This one is a OData entity set. This one represents a mapping between your base server entity, TRN student, into actual OData entity representation. Now, do not get confused when I say this, because it just so happens that in IFS as well, we use the keyword entity in base server. And also in OData, you have the keyword entity, which oftentimes can confuse you. So try not to get confused. That is why most of the times I will try my best to use base server entity and OData entity, the two terms. Whenever I say base server entity, that is this initial entity that you are creating. OData has nothing to do with this. This is completely IFS specific. And then what you instruct here is you will tell the framework that, okay, expose an entity set through a web service endpoint called TRN students, which fetches the data relevant to TRN student base server entity. And your web service endpoint will have a name student handling, right? So for example, if I open up an inspect window, try to refresh the page. This is we querying the data from the web service endpoint, or the Arena client querying the data, right? Now, if I have a look at the URL, you can see this is a OData request, right? Now, you can see we are accessing a web service endpoint called student handling SVC. And within that, I'm querying student TRN students, which is an entity set, an OData representation, right? So what happens when you write this projection and deploy it, all of a sudden, if you type this URL in, and for example, if you try to access, let's say the service document, you will get a service document like this. That's all you need to do to create a web service endpoint. So you can understand how easy it is, the development, right? And if you need to fetch the student data, you add TRN students, because this is needed first before you create the user interface, right? Okay, so that's what the projection does, creating the web service endpoint. And then to create the user interface, you introduce a file called client file. It's again a new model file that we have to work with. So I have a client file called manage students. So this is how I have added client specific user interface components. For example, I have introduced a navigate entry called student overview. I have introduced a page called student overview, and within that, a list element. So all of those elements are defined inside this client, the navigator. So it's only this many lines of codes that you need to create a new navigate entry, right? And also set a title. And then this is the page that I have created. And inside the page, I have added a list, which is querying data from TRN students entity set. And again, you have to define what the list contains. What are the attributes of the list? That is these set of fields, ID and name, which is fetched from the OData entity representation, which is again mapping to actual base server entity representation. So I believe it is quite clear what you have to do, right? Within your Arena development, all you have to do is somehow create a web service endpoint and also a client. And the client will consume the data which is exposed by the web service endpoint. And you might also notice each and every client can consume the data exposed by only a single projection or a single web service endpoint. And so this is a rule that we have. That means, of course, there's a possibility that within a projection, you can expose many different types of base server entities using a single web service endpoint. But the client should always fetch the data from a single web service endpoint. It cannot connect to multiple web service endpoints or projections. Right, everyone. So I believe this is clear to you all how this development is working, right? So can I see a raise of hands if you got an initial idea how it is working? Or if you're confused, you can let me know. And so it's very straightforward, just a simple few lines of Marble syntax, and then you all of a sudden will be getting a page. Right, and nothing to worry, we will be discussing once you deploy things into the database, how is it that all of a sudden you get a page? How is it that all of a sudden you get a web service endpoint? Those kinds of things we will be discussing, right? All right, everyone. So basically what happens is, if we talk about this projection concept, we have the business logic residing in the database server, right? Which is mostly written in PL SQL packages. And in earlier cases, for example, if you think the .NET client that we had, most of the client-specific business logic was written in the client forms, right? In our .NET client, we had C# forms, and within the forms themselves, we wrote our client business logic. But apart from that, most of the rest of the business logic was residing in the database. Things like initial validations and so on were done on the client side. But this was not very good in terms of separating the client business logic from user interaction. That is why in Arena, we have separated the client business logic from the user interface. And to represent the client business logic, we have introduced the projection, which in fact will be represented by a web service endpoint. And the client user interface is separated into a model called client. So we have a projection model and a client model. So always the client will fetch the data from this so-called projection or the web service endpoint resulted by the projection. So what's the advantage of this? Not only our Arena main client, but any other types of clients can also consume this web service endpoint. This being a web service, given you have the required authentication in place, maybe a separate third-party application running in a mobile can consume this web service. Maybe something like Microsoft Excel can also consume this web service and fetch the data. Maybe in a later session, we can show you how to consume this web service and populate an Excel table. So you can do things like that as well, right? All right, everyone. So before the break, what we will do is we will try to create the initial project that we will be working with. And after the break, we can start working with the workshop, right? So can you all access your VMs? Let me switch into my demonstration VM. And can you go to the C drive, training resources, and there should be a PDF file called Arena Development Workshop. Let's open it up. This is the workshop that we will be attending throughout the training, throughout the rest of the 6 days as well. And if I scroll through, you don't need to really worry about the requirements. So basically, if you have participated previous IFS development trainings, you know usually we have certain training specific components, TRN-ENT, TRN-INV, and TRN-ORD, which is relevant to some enterprise and inventory management system. TRN-ENT stands for Training Enterprise, which is containing some company, country, area information. Inventory will contain inventory information, and training order will contain some customer order relevant entities. And so you're supposed to develop this entire solution throughout the workshop, but we will start off with the simplest one, which is TRN-ENT. Right. Okay, so we'll start off with the exercise 1. Create your first Arena page, add it to the navigator. Most probably we'll be able to create the page, but adding it to the navigator, we can do maybe tomorrow. We will see as time permits. Okay, basically it is asking us to use some enterprise coordinator component, and we will have to actually provide you with these entities, pre-created entities in the base layer. And then you will use those entities and given data to create an Arena page to retrieve those data. So basically you will have to create a page called TRN country overview, which looks something like this. Right? You will have to manage country information using this page. And also you're supposed to first of all create a projection called enterprise handling to expose the data. Right? Now let us first provide you with this TRN-ENT component containing the base server code. We will try to deploy that into the database, and then we will start with the Arena development. Right. First of all, we will have to access the IFS Developer Studio and create a new project. I believe for all of you, you have this IFS Developer Studio icon in the desktop. Our current application version is 22R1. So therefore, if you have the latest version in the desktop, use that. But if you have 21 version also, it might be okay to use that. But do let us know if you have an older version in the desktop. Right, so let's double click on this and open up IFS Developer Studio. Right, let's create our first project. All you need to do is, so since you are all familiar with the Developer Studio from base server development experience, I don't need to really explain all the steps. You can go to File, New Project, and then it will give you IFS specific projects. You have the core project, customization project, R&D extension project, but local extensions are not really available for IFS Cloud. So this is there for backward compatibility, I believe. You can select IFS R&D core project. So let's try out a core project first, and later on, let's decide, let's try out customizations as well as we move on with the exercises. And then you can click next, select IFS core project, click next. And also everyone, I will not try to zoom in here because there's an issue where if I zoom in, you will see my mouse pointer somewhere else. So what you can do is you can use the Microsoft Teams Zoom instead. If you cannot see some things clearly, you can simply hover your mouse over the MS Teams screen share. And while you're pressing Control key, use the scroll up to zoom in to a specific location. But do not forget to zoom out as well, otherwise you might get confused in certain scenarios. Right, now it will ask us a project name, project location, and so on. Now, one thing that I would ask all of you to do is to create a new folder inside the C drive called workspace. So let's all of us try to stick to a standard. And if you have any type of a file that you need to create, please create that file inside the workspace only. Maybe you don't need to put any files in the desktop, or also try not to put anything in the D drive or touch any of the files inside the D drive. And so let's create a new folder in C, workspace. Usually as a practice in training, we give this name in uppercase so that it's easier for us to identify too. So let's create a workspace folder in uppercase. Now it is asking for a project location. Let's give that new folder that we have created, C workspace. And the project name, let's try to give, maybe you can give any project name that you like, but just to make it easier for us to also debug if you are getting any errors, let's stick to the same project name. I will call it Arena Co. Usually, as you all know, when we are giving project names, we type it in Pascal case without any spaces as a good practice or a standard. And also you will have to make sure that the project location or the project path does not contain any spaces. Right. And then you will have to select the target version here. You have an important change in the latest version of IFS Cloud in version 22 and in fact 21 R2. Now let me first of all change the version to applications 10. You can see it is asking for a build home, right? I will change it to 21R1. It's still asking for a build home, but from 21R2 onwards, they have introduced a feature where we no longer need to connect our project to a build home. So what is the reason that we have connect our project to a build home in earlier cases? To resolve any dependencies, right? But from 21R2 onwards, it's possible for the developer studio to connect to the database, find out the metadata relevant to entities, and resolve the dependency issues. So therefore, you no longer need to connect a build home here. Now, what's the version that we have to select? That is 22R1. This is always the version of the application that you are developing for. Different customers might be using different versions of IFS Cloud. You have to specifically use that version. Can you guys tell me why that is? Why is the version important, everyone?
You might be calling functions that doesn't exist in different versions.
Yes, exactly. Something like that, right? So basically, depending on the version that we select, Developer Studio will use a different version of what is known as this code generator. So as a developer, what you will do is you will develop certain model files and you will generate code and deploy into the database. The code that is getting generated for different versions will be different. Like Luca mentioned, you can have a new framework level method added in a new version of IFS Cloud that might be missing in older versions, which is why it is really important that you select the correct version. So this version has to be the version of the application instance that you are developing for. So how can you find out the application instance version? Let me go back to the Arena client. Ideally, there are a couple of ways that you can do this in IFS Cloud. One quick way of doing this is you can go to the user account settings. And at the bottom of the settings, you will see the version of the containers or different client specific containers that we are using. So as a standard, R&D uses the application version and some minor version to indicate these container versions. Here you can see it is starting with 22 R1 service update 1. Right? So that way you can decide on the application version. And also, if you search for installed components, there's a page called installed components that will indicate the major version as of now. There was a bug in 22 as well, but later on I think this will be fixed. So this version that you see here will indicate the major version 22 as well as the specific release. So that's the information that you need to set this version. So in our case, we set this to 22R1. And for some reason, as of now in Developer Studio, what you will get as update level or the service update levels is early access as well as the general availability. Above that, if you have service update 1, 2, and 3, as of now, they are not providing any specific update levels because those service updates are sent out very frequently. There will be almost no code generator changes implemented there. So that's because of that, I would recommend that you always select the closest update that is available in the Developer Studio as of now to that of what you have in the application. Right. So currently we have two options: early access, general availability. The closest one is this one. Let's pick that. Right. So make sure that you set this version, everyone. And then you can click next. And in here, when you're developing for Arena, you're only working in the database tier. You do not have to deploy anything into the services layer or the middle tier unless you are working with integration developments. And also you don't need this application feature, which is something specific to .NET. You can click next. And then you are supposed to add the database connection. So the database connection information is also mentioned in the Arena helper doc. If you go to training resources, you will have this Arena helper. And there you will find a section database connection. So each and every one of your VMs will have a database instance up and running. Service ID is IFS CLD. So the host name is obviously going to be your allocated VM. So some of you might see a database connection already appearing when you click add. In my case also, I see a database connection. Just to be on the safe side, let's try to delete any of the database connections that might appear here. And click OK. Just delete any of the already existing connections, which might be added in previous training scenarios. And then I will click add again, create a new connection, and provide the details. You can use the Arena helper to fill this up. The host name is going to be your allocated VM. In my case, it's DLK1 TRNCLD 107. Please try not to use someone else's host here because as you can understand, that can cause a lot of issues. So please double check if this is the one that is allocated to you. And then the service name would be the same for all of you. It's IFSCLD, stands for IFS Cloud. The port name would be the default port 1521. Username and password, IFS app, IFS app. And you can check the remember password and do a test connection and make sure you can connect to the database. And also for the display name, give something meaningful. Ideally, just to you can give any name here, but I would recommend that you putting the host name here so that in case you are getting any errors also, when we are debugging, we can identify your database host just by looking at the database name, the connection name. Right. After you do a test connection, you can click OK. OK, then you select the new connection that you created and click Finish. Right, and then you will have the project created called OrinaCo. And I'm going again. Please try not to create any files in the desktop or in any of the other drives or any other places. Please make sure to only use the C workspace. Even if you need to create a note or something like that, just keep it stored inside the C workspace. And another thing I forgot to mention, everyone, please do not download and install any additional applications to this VM. All of the tools that you need for the training are already installed here. Since you have an administrator privilege, you might be able to download and install, but try not to do that. Yeah. Right. So I believe all of you were able to create the OrinaCo project. Right now, if you expand this, you will see no components, but you are currently connected to the database instance. So we are trying to give you all of the necessary base server content. We will try to deploy that first, and then after the break, we can start with the exercise, Orina specific exercise. Okay, now can you go to C drive again? Training resources. You will find a component called trnent, basically a folder having the component structure. This will contain all of the required entities and additional files, source files, basically base server specific source files. Let's try to copy this entire folder. trnent, and go to the location where you have created the project. C workspace, OrinaCo, and inside that you will have the workspace. Let's paste our copied trnent folder here. So copy this from the training resources folder inside your project workspace. Once you're done, let's go back to the Developer Studio. And some of you might see the new component that we copied appearing here. If not, you can right click on the component node and select refresh. And you should see the trnent component appearing. So there you have a INS script to insert the data for all the different entities. And if you expand entities, you should see these few entities. Right. Now, some of you might be familiar with this set of entities that we are using in IFS. In most of the trainings, we have the same set of entities. Just to give you an idea about the relationships between these four entities, you can have a look at the overview diagrams. Of course, you are familiar with this from the base server concepts that you have learned. Basically, we have four entities: a country, area, company, and branch. Between country and area, we have a parent association or a one-to-many relationship. And the key of the TRN country entity is country ID. So when we have a parent association between two entities, the key of the parent will be added to the set of keys that we have in the child. So in TRN area, both country ID and area ID together will make up its primary key. So in base server, you might remember we identify country ID as a parent key, which came from the parent, and area ID is the key specific to the entity. And same between the company and branch. So company has a company ID. Company can have many branches, and therefore company ID is added as a parent key into the branch. And then you have a reference between branch and area. The reference represents a one-to-one relationship between entities. Whenever you have a reference, you're not adding a key to the entity, but rather you are adding additional attributes which can uniquely identify the referring entity's records. So our referring entity is TRN area. It contains, you need a country ID and an area ID both to uniquely identify an area record, which is why if you have a look at the TRN branch, country ID and area ID both added as just attributes, not as keys. In fact, if you have a look at the TRN branch source, you can see company ID is a parent key. Branch ID is the key of the TRN branch. So both of these will make up the primary key in the Oracle table for TRN branch. And then country ID and area ID are just two attributes, which is there coming from the reference. Right. Right, everyone. So let's try to first deploy all of this content. But before deploying, we need to do one more thing. Now, this component that we are introducing is a completely new component, which is not previously deployed into IFS. Therefore, you will have to register this component. Otherwise, your functionality will not work. So obviously, if you are working on a component which is already installed and deployed into an IFS application instance, like the component specific to units of measure. So that component is already deployed and registered. So if that is the case, you don't need to register the component. You can start development. But if it's a completely new one, you need to do the registration. So if you go to training resources, you will find a text file called component registrations, which contains some anonymous blocks to register the three components that we have. So currently you will only be working with TRN-ENT component. To register that, you can use this block. As we move along with the training, you will also register other two components too. Right. So let's copy only the TRN-ENT component registration block, including the commit and the execution slash. Just copy everything relevant to TRN-ENT. From the component registration script. Go back to your project. And you can right click on the database node in the project, get an execute window and execute this. This is nothing new to you. You'll know how to do this from your base server experience. And I will execute this. Right, and you should not get any errors if the registration has gone in successfully. So keep in mind that this is an important step. If you do not register this new component, your developments will not work out. In fact, you can test this by executing a query, select all from module tab. And if the component is registered, you should see the TRN-ENT component appearing here. So in my case, somewhere at the bottom, I might see the TRN-ENT. Oh, is it there? It's sort by module. Yeah, so here I can see the training enterprise. Right? Just to verify, you can do a query from module tab 2. Right, once you're done registering the component, then let's try to deploy our entities also. So you can select all of the entities together. Shift select the 4 entities. Right click. Okay, for some reason, the developer studio is stuck for me. Right, you can right click the 4 entities, generate code and deploy. And the table space names are the default table space names. You don't need to change anything. You can click OK for IFS app data. And you can click OK for IFS app index. And at the output window, you should not get any errors if the deployment is successful. Right. So there will be CRE files, 4 CRE files, 4 APIs, 4 APYs, and 4 APVs deployed with OK state. Once that is done, you can insert the data into the tables. There is a trnent ins database script. You can right click and deploy that to the database too. Right, and it should be deployed without any errors as well. And you can actually verify if the deployment is successful by selecting from view or table. Select all from trn area perhaps. And it should give you relevant areas, maybe branch. The data should be inserted like this. Right.
Can you show me how you get the SQL window from here?
SQL window, right. So we use the SQL window for the component registration too. What you have to do is right click on the database node and select execute command.
Okay.
Right. Yeah, so then make sure that you do the component registration too before you deploy the rest of the entities and INS script. And we can, I think, go for the break. And after break, Tiny will be taking over to get you through the rest of the workshop exercises.